example, looking at a picture and saying, okay, is there a man there, or how many dogs are there in the picture, is something that's pretty rudimentary skill, right? Sometimes we don't even think of it as requiring intelligence, right? But these were the kind of tasks which computer scientists and AI researchers were struggling for several decades to get right.
So if you start asking AI engine a whole series of why questions, like a 5-year-old would ask, why are there no pink horses in the world? And then the answer, based on the answer, go down. That would be the litmus test of whether the reasoning is more or less watertight, wouldn't you think? Welcome to the Professor Mahesh podcast. I am Mahesh Panchagmula from IIT Madras. This podcast is brought to you by IITM Global, an initiative of the Office of Global Engagement at IIT Madras. IITM Global is an initiative to take everything IIT Madras to the world at large and help them benefit from all of the work we do here at IIT Madras. Thank you to them for supporting this podcast. To help us parse this very exciting space of AI, we have Professor Balaraman Ravindran here with us. Welcome, Ravi. Professor Ravindran is the head of the Wadhwani School of Data Science and AI, which is leading the revolution in India in the world of data science and AI on many different verticals. Indic languages, I hope we'll get a chance to talk about that in a separate podcast one day, and many other such disciplines, including ethical AI. The world of AI is not going to be new to any of our listeners. This is taking the world by storm. There are many exciting prospects that are in the pipeline. We've already seen the benefits of some. And to help us understand where we are and where we could be a year or two from now, I'm very excited to talk to Ravi. So let's get started, Ravi. Thank you for joining us.
Thank you for inviting me, Mahesh.
You started your journey at UMass doing reinforcement learning, but before that at the Indian Institute of Science.
So I started working in reinforcement learning back in Indian Institute of Science during my master's, and that was in 95 was my first reinforcement learning paper. So I've been working in this space since then. Yeah.
When people were probably dissing reinforcement learning as to,
People didn't even know of reinforcement learning back then. So this thing started a few years later, or maybe a decade later. At that point, there were very few people working. In fact, there was not even a textbook on reinforcement learning back then. So we decided to write, me and my advisor at ISC, Professor Satyakirti, we decided to write a survey article. And for several years after that, the survey article used to be the main point of reference for people who wanted to get started in reinforcement learning.
And then your work at UMass Amherst honed it further.
Yes. So when I went to UMass, I worked with Rich Sutton and Andy Barto. So Andy Barto was my eventual PhD advisor, and they both recently got the Turing for their contributions to reinforcement learning. And then at that time, we were working on a lot of. Amherst used to be the happening place because it was like kind of the fountainhead of RL, right? So anybody anywhere in the US or Europe who used to work in reinforcement learning used to come to Amherst to visit Andy Barto and Rich Sutton. So we used to talk to almost everybody in the field. And when I say everybody in the field, it was probably about 30 people worldwide, okay? So that's how small the community was. It was back in the mid-90s, right? So that's... but then we got to know about almost everything that was happening in reinforcement learning back then, sitting there, and also contributed a lot to the foundational underpinnings of what now people have been building on top of, right? And then, of course, the big breakthroughs in reinforcement learning came, at least to the public eye, right? Came in 2014 when DeepMind started their initial forays into reinforcement learning.
Yeah. So today RL is obviously the backbone of almost all the large language models and how they refine themselves. And we've come a long way in the field of artificial intelligence itself. The idea was probably 60 years old. But what do you think happened for it to really become the talk of the town in the last 4 5 years?
Or lesser, 2022. Anyway, I'll tell you a little bit. So, reinforcement. I mean, artificial intelligence itself, right? So, can trace its roots back to more than 40 years. Like it's close to the 1940s, right? The very first mathematical model of an artificial neuron, which is kind of the basis of a lot of the work that happens in AI today, was actually proposed in the 1930s. So it's not that we are talking about this now, and even as early as 1950s, people are talking about artificial intelligence systems becoming conscious of their existence and then reproducing, and then and a bunch of more human-like traits are being attributed to AI systems back in the 50s itself. So it's not like, I mean, the hype is new, not like the public fascination with AI is also not new. Right. In fact, the International Joint Conference on AI is called ICHCAI, when it went to LA, right, Los Angeles, back in the 80s, the Los Angeles mayor came to the inauguration of the conference, and he said this is the largest event that has happened in LA since the Olympics. That is how big a conference it was back, like it's like 86 or 87 or something. So AI, I mean, it's been going in cycles, right? So we have had a significant hype cycle in AI. Of course, India was not very affected by it, even though there were a few academic initiatives that were started back in the 80s itself. It's called the knowledge-based computing systems that started back in the 80s, and in fact, even IIT Madras had a KBCS lab, right? That was started in 85, 86 or something, hosted between electrical engineering and I think computer science back then. So it's not that fascination with AI is new, and the public hoopla about AI was very, very big in the US and Europe back then, not in India, right? So what happened was a lot of this hype, right, was turned out to be unfounded, because AI systems, while doing great in laboratory conditions, when you started putting them out in the real world, right, they were not able to scale. There are so many, starting from simple engineering questions to access questions to guarantees of performance, stability questions. All of these were not answered back then, and so when people tried to build, public-facing systems with AI, things were breaking. Right, they were very fragile, and so since the promise was not followed by delivery, so people's fascination quickly died out. The first thing that went away was government funding, right, and then the military funding stopped, and then of course the AI hoopla just died down, right. So when I was starting my grad school in mid 90s, right, I started in 93 actually. You could see that there were a lot of people who were not in core IT areas who are doing a lot of AI. They were actually looking at whatever technology that had been developed by the AI specialists and trying to use them in their own domains. But the core AI research itself had started shrinking. Right. So I was probably the last generation of people who actually worked on neural networks back then. Right. So my master's thesis was on neural networks. Right. So reinforcement learning and neural networks, and kind of died away after that. Right. So by the time I was graduating, if you say that you're working in neural networks, you couldn't find a job. So that's how bad it had become, right? So, but then what happened was in 2012, right? 2010, 11, 12, around that time, there was a huge revival in neural network research. Right, it's called deep learning now. We know it as deep learning now. So what happened then was that Jeff Hinton, who many of you know because he won a Nobel recently. Ironically, this was not for what he was awarded the Nobel, but he, along with a student of his, right, Alex, I can't pronounce his last name. They basically built something called AlexNet, right, which was a multi-layer neural network, if you will, right. And I mean the basic premise behind neural networks is the computation is organized like it happens in the brain, but they came up with this multi-layered neural network which was able to advance the state of computer vision, the level at which the computer programs can recognize objects and images. right? They were able to improve the state of the art by 15%, which is a huge jump in performance. While people year on year were able to improve by 1 or 2% because a lot of engineering had gone into these systems already, but these people were able to get a 15% improvement in performance with just a very simple, conceptually simple model, but something that required a significant leap in our understanding of how computation works. And so that really caught people's imagination. Within a very short period of time, these deep networks were able to do these object recognition tasks better than humans. Okay, so there's a somewhat ironic thing about quote unquote what we call intelligence, right? So things that we typically think are higher order intelligence, like playing chess, right? Or proving theorems, like doing strategy games and stuff like that. AI was able to crack a decade or so earlier than things that we take for granted, like computer vision, right? So, for example, looking at a picture and saying, okay, is there a man there, or how many dogs are there in the picture, is something that's pretty rudimentary skill, right? We don't really, sometimes we don't even think of it as requiring intelligence, right? But these were the kind of tasks which computer scientists and AI researchers were struggling for several decades to get right. Right, so people could I mean, vision and language, right? Trying to understand spoken language and things like that. Even forget about irony and innuendo and other kinds of things. Even straightforward English sentences, trying to parse them and trying to understand the meaning, was actually pretty challenging for computers, right? And so it was a huge revelation to the AI community that vision, which was a hard problem which people had been trying to solve for more than 4 decades, right, had been struggling. And here was this model which didn't use any of the standard engineering tricks that people had built over 4 decades to solve the vision problem and could get better than human performance, right? So that really amped up the interest both in the research community as well as the funding community and as well as in the industry, right? In reviving interest in AI research, right? So and AI came to be deep learning for a while, right? So and that's and you had a lot of these amazing breakthroughs come because of this deep architectures that were now enabled thanks to Hinton's breakthrough and a bunch of other people who followed up and then who came up with better methods to train these models than what Hinton's breakthrough was, right? And all the both the Nobel, right? So Hinton's was on training multi-layer network, and then the chemistry Nobel also went to AlphaFold, right, which is a AI method that could discover protein structures, right, and that also was again enabled due to deep learning and of course reinforcement learning to some extent, but largely because of the advances in deep learning, right, and so people started getting more and more interested in this, but the true tipping point in some sense where everybody and their uncle and the politicians and common people have started talking about AI came with the release of ChatGPT. December 2022, December 1st, 2022. Yeah. So, I mean, I even have the tweet which Sam Altman said, oh, we are happy to announce the availability of ChatGPT and things like that. And so that really opened up, right? The AI I shouldn't say AI revolution, but it really opened up AI to the general public, right? So the biggest thing that ChatGPT did, right? It is not that you know not that people weren't using AI before. Every time you fire up your Google search engine, you are using AI, right? So every time you use Google Maps, you are using AI. Every time you order something on Swiggy, you are using AI. Right? Swiggy is using AI to come up with a prediction model for how long it will take for you to get your food, right? And every time you use Amazon, right, order something on Amazon or Flipkart, you are using AI because they use AI in order to figure out how to group things when they are shipping things stuff to you and etc., how to optimize for their warehouse performance and things like that. But in almost all of these instances, right, or if you're talking to your Alexa, right, so you are using AI. In all these instances, there was an application. AI was something that was driving the application, right? But ChatGPT was an interface, a raw interface to a highly capable AI system, right? So that was never the case before. You always use it for a specific task. Now you could use ChatGPT for whatever task you wanted.
You could design your own application.
You had a highly capable AI system. So there are two things here. One, People were not exposed to anything of this sort ever before. This is a first of its kind experience for 90% of the population. So people who were in the field, right, who are in the industry or who are doing research in this field, were surprised at how good the system was, but they were not as amazed as the general public was, right? But this sudden step up in the level of exposure you had to the capabilities of AI was really what caught the fascination of the public, right? So, and that's why everybody started trying out ChatGPT and so on and so forth, right? That's the first part of it. The second part of it was OpenAI took the huge risky bet of making AI the product. Right? Nobody, no, I mean, none of the other companies, even though they had equally, more or less capable, equally capable AI systems with them, nobody thought of making that as the primary product because they had other sources of income, to be frank. And this is something which I think Sundar Pichai said around that time, either December 22 or Jan 23, when he asked, hey, doesn't Google have the capacity to do this? He said, yes, Google has the capacity to do this, but we also have a reputation cost. Because when ChatGPT was released, right, it was far from perfect. There were a lot of mistakes it was making. Hallucinations were rampant, and you could make it do all kinds of silly stuff. You could make it say crazy things, right? And you could really derail it. And you had all these instances of ChatGPT professing its love, undying love and affection to the person it was interacting with, asking that person to leave his wife and come move in with ChatGPT and things like that. I mean, all these kinds of craziness was happening when these models were coming out, right? And so it was obviously not something that was really ready for large scale deployment, but OpenAI went ahead and did it anyway, because that was their way of creating excitement about their company, and so that they could get people to come in. So it was a very calculated move, right? So others couldn't do that. Like Sundar Pichai said, it would have been a significant reputational harm for Google. Even afterwards, when they actually followed suit, and there was some simple mistakes that Google's whatever Gen AI did, right? Bard did. That was a huge backlash on Google, right? Even though OpenAI, ChatGPT was doing far sillier things than that at that point, OpenAI got a free pass because yeah, they're a small company. It's okay. They're trying something out. It's an amazing new technology that was there, and the things that it got right was sufficiently exciting that people kind of ignored the things it was getting wrong, and slowly the engineering kicked in and people started fixing it, the model started improving, and so on and so forth. In some sense, ChatGPT coming out in fact increased the investment in AI manyfold. Because of this excitement, people who had never looked at AI as a serious investment opportunity started pouring money in, right? And all he needed to say was, I am building a product based on an LLM, and then you had VCs writing like $1 million checks for you without even knowing what product you were building, right? So that's the kind of hoopla that got generated. So far, we have not had a huge negative fallout so far. Um, yeah, so hopefully, I think we will continue improving.
I think the reputational risk you talked about and the failures are all as much an integral part of any successes journey. You look at India's own space program or the US's space program, they were not without accidents, they were not without failures. So I think it's great that the society at large, led by the investor community, led by the startup community, has taken this bull by the horns and they're trying out some things. I think only good can come out of good trials in some way. So, what among all of these things that are happening around us, what changes truly excite you the most today in terms of having potential for the next year or two? Where do you see LLMs are already largely capable of let's say working in English, and they're able to write code. What what are some of the sort of the bleeding edge of these changes that really excite you?
So, one of the biggest challenges that LLMs render moot is that of communicating with computers. Communicating with, see, it's not that we didn't know computers can or amazingly capable automation systems, right? So as long as people are able to write the right kind of programs and right kind of applications around it, computers can do a whole bunch of things, right? In fact, as early as I'm going to say 99, 2000, maybe 99. So there was this very ambitious project called Electric Elves. Okay, the idea of Electric Elves was to create your digital persona and let your digital persona act on your behalf on many instances, right? So including starting with simple things like, ordering food for you, making reservations, etc., and also to attend meetings on your behalf, and also take notes, and kind of represent your well entrenched positions and stuff like that. So Electric Elves was a very ambitious
Wait a
initiative.
minute. I can have an electric elf attend a Zoom call on my behalf today?
No, not yet.
Not yet.
Yeah. So
Okay.
you can have a Gen AI model attend a Zoom call on your behalf, take notes, and then and convey the notes to you, and it can summarize what happened in the meeting and so on and so forth. But it cannot represent you yet. But it's becoming possible.
I mean, my video can be synthesized. Let's say I'm turning off my video. I think it's a matter of getting my audio right and
Getting your thought process right. Right. Audio right is possible. Audio cloning is very much possible today, right? But for it to be able to think like you do and give an answer that you would have given, that is still a challenge, right? And would you legally accept?
well, yeah.
All those questions would come, right? Somebody goes and
I can only imagine a bunch of electric elves meeting. It's not great.
and coming up with a decision which none of the people humans actually agree upon, right? So those kinds of. But the point is, we're not too far away from that kind of a technology, right? So people could conceptualize all kinds of amazing things that you could do with computers and automation, even several decades back, right? This is almost 2 decades ago, right? And people could think of those things back then even. But now, with the communication problem being largely solved, right? I think we can really start pushing towards building these kinds of amazing tools, right? Whether it is when people talk about tutoring systems, it is almost always canned answers, canned lessons, right? And when you talk about how people talk about personalized tutoring, right? Personalized tutoring would used to be something like, okay, I'm going to pick which lessons you are going to learn next based on what you have learned so far. But to build a system that can teach you in a way that you are more receptive to understand, right? That required a lot of effort, lot more investment, and so people were not really ready to do it. It would have been at something at a very high level. But today, I can actually conceptualize having a model that's going to interact with you for a few hours and then figure out what is the best way to talk to you, so that each and every kid, or not even kid, even an adult who is trying to learn, can have a tutor that talks to it in the language, in a dialect, or in a way the sentences are framed, right? So that it's best fit for you, right? So these kinds of things that can be done. So solving the communication problem opens up a lot of doors. And what LLMs have
This
done,
is
what they
almost seeming like what the touchpad did to the phone versus a old QWERTY keyboard. You say we've crossed that hurdle with AI now.
yes, largely. So 5 years down the line, everybody's going to just talk to their phones. Voice is going to become the primary mode of interaction with computers, phones, everything, right? All digital devices. So you're not going to have keyboards, and we're not going to have input. The voice is going to get so good, right? And so that's what we have to plan for in the future. Already, people, especially in India, I was told that the adoption of voice interfaces, voice queries, is the fastest in India.
Because we probably, in some sense, leapfrogged a keyboard generation.
We leapfrog the keyboard generation, so we don't do typing. So the adoption is much faster in India. In fact, yeah. So even voice queries are growing at a much faster rate in India than in other geographies and things like that. So I think for us, even without this capabilities of this LLM, I'm talking about the old generation voice interfaces that Alexa and Siri and other things, right? So even those generation we were able to adopt. Now all of those guys have moved to LLMs, right? So they are not using the old generation voice recognition, but but with the flexibility and the ease with which you can tune these models, right? I think a lot more doors have opened. So I think that is one of the biggest changes that LLMs have brought about, not just in text and speech, and but also in graphics and imaging and stuff like that. So a lot more is possible now, just because this interface problem is solved.
That's a very nice way to parse why the progress is happening. Thank you. Let's talk about your work here as a professor and leading the Vadhwani School of Data Science and AI. You've interacted with the people from the industry across the cross section. Um, and everybody has two views of AI. There is a group that says, I'm talking industry people. I'm sure a large fraction of them are embracing AI for their own processes and products. But on the human side, there are most of them seem to be a bit wary in terms of what this could do, what all this could do. Therefore, they're sort of being very conservative on the hiring end. Let's talk about careers. How is AI going to change the way people do their work? What sort of new career paths enabled by AI, and some old career paths that could be morphed into something new by AI? What do you see happening? Help me with help me peer into the crystal ball and understand where this goes.
Sure. So, of course, when you're talking about people are being cautious about AI and all that, it's just outside Silicon Valley, right? So within Silicon Valley, they're all crazy about AI, which is that's one of the things that gives me a lot of pause, because running headlong into this. So let's talk about this. There are a couple of things I want to say. So one thing is, almost all jobs, right? Almost all jobs that we do now, we're going to have certain aspects of the job that is easily doable by this generation of AI, right? Or Gen AI, as people call it. I meant generation, not generative. Whatever this, whether the Gen AI foundation models or whatever is the current wave of AI you want to name it, right? These can do certain aspects of their skills very well, right? Perhaps for most jobs, it cannot do all of it well, right? So, for an example, right? So you might take let's take a journalist, right? I mean, so AI can possibly write an article in 15 different formats, right? But a journalist would still have to bring in their insight in terms of, okay, what is the right article to write in this particular context, right? So looking at what is happening in the outside world, I mean, imbibing a lot of it, doing your fundamental research, you can use this AI models to do the research for you. It can read a lot more news sources than a human being can effectively do, summarize things, give you bullet points that you can consume, right? But then there is still this journalistic intuition that tells me at this point, this is the story that I have to write. And then the AI is going to help me write it more effectively, right? So, but then that's still that piece, right? It's kind of an indefinable piece as to what you as an individual bring to that, right? Your viewpoints, your I wouldn't say biases. It's not the question of you're bringing your biases, but that could be it, right? And also bringing a lot of history, your interaction with the world, and your past articles that you have written, and so on and so forth. Your experience that you bring in, right? That individualistic thing is still not available with these AI models. I mean, you can say that, oh, write this article as if a journalist with 15 years experience writes it. It'll give you something, right? But to say that write this article that I think that I should be writing now is something that's still, there is a gap, right? So it will give you an output, obviously, but it might not be the best output. Like that for almost every skill that you take out there, right? There will be some aspects of the skill that can be done better by these AI models, and still some aspects of the skill which you still need the human with their several years of training and their skills and their innate ability to do some things are needed. So one example is in music, right? Now you have some amazing music producing AI systems. I don't know if you have played around with any of them.
So I have a little bit, but not the amazing ones.
Oh,
Because
yeah,
I was
some of
not.
them are really good. Okay, there are, but then it's not really as captivating. The music is pleasing to hear, but then if you have a human co-create the music with the AI, right? The human comes in and says, "Hey, can you use a different instrument for these 15 seconds?" than what you have used? Or can you increase the tempo of the music at this point? Can you reduce the tempo here? Can you add a voice here? So then it just keeps doing that, right? But then at the end of it, you get a lot more interesting music than you would have gotten if you just let the AI generate things by itself, right? So this co-creation is something that's going to become a lot more common way of working, both for artists and for regular people. I mean, even an accounting job, right? So I jokingly say that creative accounting will get a new meaning if you start using generative AI. But so then. You could co-create stuff, right? So you could ask it to generate all kinds of new reports that you never thought of doing and stuff like that, right? And same thing applies to stuff like programming, right? So this is something which Andrew Ng recently said in an interview, right? He said that a lot of people say that you should stop learning programming because AI will do all the coding for you. Andrew said he gave this example of one of the courses that he was teaching, right? He wanted to create a cover page for the course. So he used one of these Gen AI tools that generates images and asked it to generate some image for the cover page, and it did. He was not very happy with it. So he engaged a professional artist who used the same tool that he used for creating the image. He just still made calls to the AI, but he produced something that was far more fascinating and engaging than what Andrew could produce just by him blindly interacting with an AI. So he said, just like a trained artist can get a lot more out of the AI, a trained programmer is going to write better code using AI.
Very interesting analogy, because I think the idea of a tool of AI ultimately being a tool in someone's hand, right? And it's the person wielding the tool that is the producer of the output, right? The
Can I finish what Andrew said? Because it's very relevant for our discussion, right? So he said, therefore, he claims that more people should learn programming now and not less, because programming has become easier. So you don't have to worry about syntax. You don't have to worry about debugging. Like, you don't have to worry about packaging. You don't have to worry about all these other software engineering stuff that was happening. You have to worry about design. You really have to think about, okay, what is it that this program should do, right? What is the actual problem it should be solving? What data it should be operating on? How should it present the output to the person? You can go back and say, no, 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 please don't do the UI displays, do it another way and things like that. But then you need to be trained in what is good code design, right? So what is modular design, right? So what works well with what, right? And those kinds of issues with regard to broader software engineering concepts rather than learning more about syntax, right? What is the most efficient way? Can I write this code in 4 lines versus 3 lines? Don't worry about it. You can ask the AI to keep optimizing the code so that you get a 3-line code instead of a 15-line code. But you need to understand what is good code design so that you can actually direct the AI in a proper way. And that is becoming easier. So some people who understand domain well can also be taught how to write code well for that domain, right? So more people should be learning programming, not less. That is the argument that is making.
That's a good first early message for our listeners. This is a great time to get into programming, but as you learn programming, learn to adopt all of the AI tools that are available to all of us at a very reasonable cost. They're mostly free, but there's also exceptionally good capability that comes available at a very reasonable cost. Let's talk for a minute about India now. Yep. India has long been um, active in the IT space, in the IT consulting services. Indian companies are among the top. Um, Job market in the space of AI and machine learning itself is really been booming. Last year alone, there was a report I read that said there was a 36% increase in the number of positions, and my gut feeling is that was a conservative estimate in just AI ML related jobs. What are some really high in demand AI roles? And we will start with that and then work our way through the value chain to understand what are all the different roles that AI is creating that probably didn't exist before AI came on the pipeline.
So I really haven't done a very careful market survey to be able to rank which jobs are more in demand. I can tell you what's happening in some sense, right? So there are two kinds of AI, high end AI jobs that are being created now, right? That are in demand. So the one which a large fraction of people are looking for are AI engineers. These are people who can take these AI tools that are out there, right, and create innovative services around them, right? They are problem solvers. They are not doing research per se into the nitty gritty details of AI, right? But they are taking the tools, the building blocks that are out there, right, and then using them to create innovative services, right? A lot of these big companies, like whether it's TCS or Infosys or Accenture, those guys need a lot of these because their clients have problems that they need to be solved. A good fraction of these startups that are there in the Indian ecosystem right now, I mean, some of them call them disparagingly wrappers around LLMs, but they are not. I mean, they are actually put in some amount of thought and some amount of design in order to create the solution where the core AI is provided by LLMs like GPT-4 or Claude or whatever. But then you really need the system around it, right? So the AI itself quite often forms 30% of the solution. 30 to maybe, if you're a little generous, 30 to 40% of the solution. But you remainder 60 to 70% is something that you have to really build around it, right? So the AI engineers are people who are able to do that, right, and then build robust solutions around these. So this is one class of job.
So just so I'm a layperson here, what you're suggesting is, let's say I take a Perplexity or a ChatGPT AI API, and then build a layer that a customer can really start to deliver value, derive value from. Okay.
And it's not just use the raw AI. I mean, that has to be a little bit more. For example, right? Let's say that I'm using this AI to build a service that can advise farmers as to what they need to do. Right. So now it's not enough for me to just build a chat interface to the farmer. Right. I need a knowledge base behind it that's going to talk about, hey, what the farmer needs to do. It's say in Vishakhapatnam versus what a farmer needs to do in Ludhiana, right? So that information somehow has to be fed into this model, right? So you need to create this kind of a knowledge base. You need to create a data set around this, right, which this AI is going to query. It's going to form the answers. It's going to understand your questions, right, and then kind of reason about those questions. I'm putting reason within quotes here. I'll we can talk about it later. So kind of reason about this question, figure out what exactly is the piece of information you are looking for, and then go back to the knowledge base, get that piece of information from the knowledge base, and present it to you in a form that you can understand. The knowledge base could be in Hindi. You might be asking questions in Punjabi. I want to give it to you in Punjabi. So the core AI is there, but it is not just a question of writing the wrapper around it. You have a lot more work that you need to do so that you are able to provide the service that the person wants.
Ultimately, for it's like you going back to your Andrew Ng example of designing the cover page. A good cover designer knew how to use the tool. So, a farmer that does not know how to use the tool requires an intermediate layer in some sense, a knowledge base that is acting as an intelligent prompter. Is that a way to parse this?
Not really. So in that the Andrew Ng's example, the farmer, I mean the artist is in the same state as the farmer, right? So it's not like the artist is actually adding knowledge to the thing, right? Artist was actually asking a series of questions or making some modifications to what the output was. He was not actually adding anything to the system. It was just limited to that one interaction that the artist was having with the system. But here, the farmer is just asking very simple questions, right? The farmer is not doing anything more. But the system itself, which was more of a general purpose language system, has now been tuned into being a agree question answering system by the AI engineer and by the system designer, right? So the system designer is actually created. For example, the graphic designer was using a bot that could generate images, right? Uh, Designed to just process language, not process agricultural knowledge, right? That agri knowledge processing is what has been brought on board by these AI engineers. So it is not just a question of making the interface more rich, but it is a question of actually augmenting the capabilities of the underlying AI model, but not touching the AI itself. We have not done anything new for transformers. The pathways for doing the augmentations have already been built into these AI models, right? And you are just taking advice. So you are a person who knows what is the right piece that you need to plug in to this system so that it can solve the problem that other person is asking. That's why I keep calling them as AI engineers and not as AI scientists. Or
Very nice, very good. So these AI engineers, in some sense, sit at the top of the value chain. AI researchers sit higher, uh, and then what are the other jobs that AI is and data science broadly is enabling for people across the spectrum?
the bulk of jobs that have been created so far, right, are these AI engineer kind of jobs, right? So what is going to happen as the AI starts becoming more prevalent, right? So there are a few more roles that will get enabled, which I see is going to happen, right? The first role would be what I'm going to call as AI operators. Okay, imagine back in the day when we used to have STD booths and things like that. So people used to go to these booths and somebody used to call for them and then say, okay, are you there? And then hand the phone to you and you could just talk, right? Those guys. So you're going to have AI operators. You're going to get highly capable AI systems. But the farmer, like you said, is still going to not be able to use the AI system effectively, right? So he's going to come to a place where there's an operator sitting with like, okay, 10 different things. Okay, healthcare, okay, I'm going to query this AI. Farming, I'm going to query this AI. Things like that, right? So that guy is going to answer all kinds of questions for you, and he probably would also have an astrology bot in there somewhere, and we are never going to move away from that, right? So all of these, so you're going to have these kind of AI operators, right? So that's one kind of role I think will happen, right? In fact, it's actually the small scale is already happening. So there are people who offer this service in the villages. You tell them what you want. They order it for you on Amazon and they take a 5% fee.
Huh. Okay.
Right? People don't know, they don't know how to use these tools, and then so they basically have these guys who come and order stuff for them, Amazon or Flipkart, whatever, right? So they basically do this online shopping, but somebody else does it for them and takes a small fee from you for doing that. So these services are already there. So these kind of operators are there, right? So I think this will just expand to AI operators. So that's a more non-technical work that's going to come. The second kind of thing that's going to get enabled are AI auditors, right? And these are people, of course, like just like you do tech audit now. So these are people who are going to do AI audit. It's going to be slightly more expanded than just doing an audit of your software, because you're going to have to do an audit of your entire pipeline, right? So you need to understand things like, hey, where does this interact with data gathering? So you have to do look at things like privacy and how are you storing the data, and start from consent and things like that. So you should be able to do an audit of that pipeline versus your model building pipeline, and then your testing pipeline, and so on and so forth, right? So there is a whole bunch of different sets of skills that are going to be needed. And I think as the field develops, as standards develop around the various aspects of the AI pipeline, you're going to have this whole ecosystem of people who are going to ensure that you are building these with regard to standards, compliance specialists, and those kinds of roles will start coming up, right? So I think that'll be another. This will again be people who will be in high demand and will be very highly paid. That kind of a role will happen. And then I do believe, even as AI becomes more and more capable, right, we are going to start moving towards what some of us call a human allied AI pipelines, like human allied AI pipelines, right? So where sometimes you have a human who is making decisions and the AI is giving them input. Sometimes you have a human advising an AI, guiding it to take inputs. So, but this human is also monitoring the AI's performance to see if there is a drift in the performance and things like that. So you're going to have these kinds of AI managers, right, who need to be in the loop, right? So this will be people who have core domain skills, because they need to understand what the domain is, whether the AI is actually meeting with the demands of the domain, etc., etc. But they also should understand how the AI systems operate and how do they intervene and things like that, right? In fact, some of the more fanciful terms could be that these are the guys who control the kill switch for the AI. Okay, but then let's not even go there. You don't even if you don't want to get to the kill switch, you still need somebody who is going to be in the thing and monitoring what the AI is doing, right? So it could be like it's not AI operators, but people who actually work with AI. You can think of them as AI managers. So that's another kind of role I see is going to become important, right? But one more role, which is already starting to become very prevalent, are the data workers, right? So data workers are people who generate the data, right? So earlier, in the previous generations of AI, right? So where you are actually building these AI models to do predictive modeling or decision making and so on and so forth, you were looking at data being generated by experts. So you want to generate a medical data set, right? You go to a doctor, right? You want to generate something else, right? So you go to a specialist in the domain. You go to a lawyer. So if you want to get some law data sets and everything. But now what is happening is these Gen AI models are able to consume a lot of language data, conversational data, and image data and things like that, which general public can generate with a little bit of training, right? I mean, to identify whether something is a bus or a car, right? I mean, you don't need an expert to do that. You don't need an expert in transportation to do that, right? Somebody can come and do that. Or to recite a poem in Telugu and record it. So somebody with good knowledge of language can do that. They just need to know how to speak into the mic. When do you start the recording? When do you stop the recording? How do you use the interface? A little bit of training on that, right? They should be able to generate, volumes of data, right? And likewise, people who can narrate stories, local myths and legends, right? Because we need to record these, because as we go along, right, AI and search engines have, if Google doesn't return a hit, we don't know about it, right? In fact, ironically, this happened to me a little while ago. I actually wanted to find out something about a festival that happens in my hometown. I, I mean, I had been part of it when I was a kid, right? So I didn't remember all the details of it. So I actually went and Googled. I got a lot of noise. I couldn't find out details about this festival, right? Because I was actually looking it up to write an article that said I wanted to say exactly this point, right? Because of all these LLMs, not trained to the local nuances, you are going to lose a lot of knowledge, right? And then I asked my mom, right? So I asked her, hey, what about this? She said, no, yeah, you should have used this particular triggering phrase, right? That's the thing you should look for. Right. And then I went and actually searched for that. And I got some valid results. But the point was that could have very easily gone. And Tamil Nadu is a place where a lot of people are IT savvy, right? So these things will get captured. But then in most parts of India, these kinds of nuances are going to go away, right? So I don't think my son has ever experienced that festival, and I don't think he will be able to find it that easily on Google. So these things will go away, right? So we need people who can actually create data sets around these, right? So, and we need to figure out how these things are going to happen. So these kind of data workers, right? The field of data workers, right, has now become much. The scope of data work has become much larger, right? And there are organizations. So Karya is one. One of our alum is a co-founder of Karya, Vivek Sheshadri, and so these guys have been doing this amazing stuff, right? So they record people just reading out certain scripts, right? So because they want voice data, so they are recording these women particularly because women voices actually are very less represented in most of the training data that we have. Mostly we have men voices. So women voices. So they've been asking women in villages to read out passages. And what they do is something interesting. Apart from giving the women just a small amount of money for doing the work, they keep track of every piece of recording that the woman has made. And if somebody uses that piece of data for training their model, then they track the use of that model as well. And whenever somebody uses that model and whenever income is generated, these women get royalty. It could be as little as 1 paise for every use of that model, but still, apparently, these things add up. And some of these women who have been prolific in their recording, not that they spend all their time doing this recording, but they've been reasonably prolific, get up to $200-300 a month in salary. Just not salary, it's just in royalty payments and stuff like that from the downstream thing. So there's a huge potential for this kind of a data economy to bloom as long as the industry adopts this kind of more ethical data practices like Karya is, and a lot of backing. I mean, Karya is not the only org, but but there's a lot of backing for efforts like this now by the bigger companies as well, and also for some of the other NGOs and other organizations. They're also backing this. Yeah.
Very interesting. I think clearly there's a hierarchy of opportunities that are going to emerge from this adoption of AI. Um, is one sector going to be more sort of affected or influenced than others? For example, there are sectors you talked of agriculture, farming, and on the other end of the spectrum is in some sense the other end of the spectrum is healthcare, which is very safety driven, very um standards driven, where human intervention is almost written into the code of operations. Do you see different sectors being differently influenced, and or is this wave so big, is the tsunami so big that almost everybody will take note and change their code of operations?
Everybody will get affected, not necessarily to the same extent, but certainly will get affected. I mean, agriculture, right? Because there's so much physical labor involved in agriculture still. So until we have commensurate advancements in robotics and making it cheap enough to bring it down to the level where automation can actually get into the field, agriculture will still be largely physical labor driven, right? So some of the quote unquote intellectual activities in agriculture, like, okay, what should I do for my crop now? Is there a disease? Or can I cure it? What fertilizer to do? What crop should I use now? How is the weather going to change? What should the pricing? Which market should I take it to? These kinds of decision making, higher level economic decision making with regard to agriculture can potentially get affected immediately. But some of the other things like, okay, how do I go about planting things? And of course, there are, I mean, some of the companies have actually been very, very aggressive in getting automation down into the fields, because partly because all the manual labor in the villages all driven to the cities now. So there's nobody left to work in the field. So people are actually moving that direction as well. So depending on what kind of, like, imagine I was telling you, remember I was telling you at the beginning that different skill sets in a job will or are more amenable to automation by AI, and some are not. So depending on that mix, right, you're going to see a larger, lesser impact or greater impact, right? So healthcare will see a large impact actually. So people are beginning to take note of the benefits of AI in health, and they are actually talking about changing regulations.
So one day my chest X-ray may be read by an AI radiologist.
Today,
Today it's still signed off by a human radiologist.
but it's read by a AI radiologist first, yeah, and the human radiologists apparently started getting this. Some of the more modern X-ray machines actually are giving an AI generated report for the human radiologist to look at already.
Okay. So that's a change that is this is like an extremely competent IPL umpire reporting to a computer DRS system.
No, the computer, I mean, the umpire still takes the input from the DRS, right?
No, but the DRS, the umpire on field, is in some sense subservient or can be overridden by an AI DRS.
Right now, the doctor, the human radiologist still can override the AI radiologist, but they are getting their input. And apparently, increasingly, this is a study, this,
Human lineman is overridden by
yeah, computer line.
the
Yeah,
computer lineman.
yeah,
So
yeah. In some sense, that's fine. It's simple enough that they can do that, right? But I actually I really want to. So we are beginning a study, right? I actually want to see how often would doctors and like the radiologists would accept the findings of the AI, even if they are given the freedom to override it. How often do they say, "Oh yeah, this model has said this, so I'll say it should be right," kind of thing. So so I think attitudes towards AI are in major flux, and some countries are extremely skeptical of AI. I was recently talking to some folks from Australia, and they said that Australians are apparently one of the most skeptical countries about the adoption of AI, which I found very surprising. And India, surprisingly, we are actually very pro AI, very open to using AI. So the human, I mean, the attitudes towards AI is also changing. That's also going to influence how soon things get adopted.
of course, I mean in all democracies, the amount of money that comes available is in some sense tied to public opinion. So it will have to go hand in hand. If I'm a young student and listening to all of these opportunities, listening about, where do I go to get started? If I want to become an AI engineer, if I want to become, like you said, an AI operator, what are some communities that are forming? What are some areas? Where's a good starting point?
So there are a lot of AI resources that are out there, right? So some of them uh, are at a very tool level. You learn how to operate tools and things like that. If you've already done a good computer science program, right? You already know some of the things about algorithms, how to construct programs, things like that, and so on and so forth. Then maybe, right, you will get significant benefit out of going to some of these tool only training programs. Right? A lot of these are available online. So I don't want to mention names and give them any plug. Yeah, but many of these are available online. But the challenge with this is, right, like I said, it is superficial. So you learn how to use a current set of tools, and then when the set of tools change, then you become a little bit more. So unless you have strong fundamentals in code design, in algorithm design, and things like that, even if you don't have a strong AI fundamentals, right, you can still get by working with these tools, right? But if you're starting afresh, right, I would strongly recommend going through a program with good fundamentals, right? So one possibility is our online BS program in data science, and we do have a very large funnel for people to get into that. The ITBS online BS program is there, and there are many colleges now, right, that offer different flavors of AI. I mean, there are like starting from BSc programs in artificial intelligence now. There is a BSc AI, apparently. I didn't know that. Certainly, BSc in data science is very, very prevalent. That's out there. And then, of course, there are a lot of bachelor's programs in AI, computer science plus AI, computer science plus data science plus AI and machine learning. I can keep going. I mean, there are some colleges, some private universities here that offer 10 different degrees with AI in the title, right? So, but the challenge is, how good are they, right? It's not clear, right? There's no quite a, there's, I mean, these have not been ranked yet on how good their AI things are. The cohorts haven't come out and so on and so forth. So if you are considering going to one of these private institutions, right, the one rule of thumb you should have is they would have computer science programs that have been in existence for a while. So it's not, even though it's not a like for like program, but you could see how good their computer science programs are, how good their placements are, and how good how large their program is, what kind of reputations these computer science programs have. Typically, you can use that as a good proxy to decide if they are going to have a good AI program or not. And so that's the way I would suggest you go.
So let's go back to this. You raised the you talked about different degree programs that are in vogue today. Let's take engineering degree programs. The All India Survey on Higher Education, the last report that I had a chance to read, says we have about 24 lakh engineering students, of which about more than 12 lakhs are studying computer science plus plus. That plus plus includes AI in healthcare, AI flavors in some sense. So help us understand, what would a BTech computer science do? What would a BTech AI be able to do that would be slightly different from the BTech computer science? How much is the overlap and where are the differences?
Unfortunately, the way the AI curriculum is now being taught broadly in the country, right, is that it is computer science plus plus, right? It's computer science mostly with a few courses on AI, right? AI, machine learning, deep learning, like 2 or 3 additional courses that the students do along with computer science, primarily computer science courses, right? So I believe that's not the right way to approach this, right? So I think the person who really needs to uh, uh, get into fundamental AI work, not necessarily the AI engineers, but people who really want to get into changing the AI systems, coming up with the next generation AI systems, require a different set of skills that they need to. If they pick it up at the undergrad level, it will be good, right? So we want them to be a lot more conversant with mathematics, right? Which most traditional computer science programs do not teach them that much math, right? I mean, ideally, an electronics or communications engineering student or a mechanical engineering student would pick up a lot more continuous math than a computer science students. Computer science students typically pick up discrete math, but a large fraction of the math behind the modern AI systems are continuous math. They're not discrete math. So we have to starting from there, right? So we have to start teaching the students a different kind of mathematics than what the computer science students learn. It's not new math, right? It's just different kind of mathematics, so including things like probability theory, optimization, linear algebra. All of these things they have to learn, right? In fact, optimization is something is becoming more and more of a fundamental skill. They need to understand optimization. It shouldn't be left as an elective, right? Most curriculum they students take optimization as an elective in computer science, if at all. Right? So that's something that we need to fix. And then if you start thinking about at a very high level, if you're building AI solutions, right, you don't really need to get into some of the uh, core computer science topics, right? So things like compilers, right? So how would you translate a program into a machine code, right? So that the machine can execute it, which is a very fundamental skill that a lot of computer science students learn, right? But somebody is going to do AI. I mean, if your job is going to use AI to write this program, you really, I mean, at that level of abstraction, you don't really need to do the uh, machine translation things. So some of these fundamental subjects in computer science, like compilers and so on and so forth, right? You would kind of not want to emphasize too much for the AI students. Maybe do it as part of a systems course, but not necessarily do it as a separate program, right? So like that. So there are multiple points of difference, right? The depth at which you cover certain topics in computer science. Just like when we created computer science as a separate topic out of electrical engineering. Right before that, everybody who's wanted to get into computer science were electrical engineers. Right? So then you don't now in computer science you don't teach people at the level of transistors and gates and so on and so forth, which used to be part of your computer science curriculum when computer science separated out as a subject, right? Because that people thought that you need to understand how the basic circuits are hooked up so that you'll know how to program them later. But the programming abstractions have become so powerful that people don't need to look at that anymore. So like that. And so in AI, you don't really have to look at the computing abstraction in some sense, right? To know how to write better AI algorithms, right? So some of the AI aspects still need you to have a very close interaction with some parts of computing. For example, a lot of AI systems are becoming distributed. That's what they call it. Right? Distributed means that you have different parts of the programs running in different computers, and then they have to talk to each other and so on and so forth. So you have to understand how these distributed systems are constructed, right? So that you know that there are delays here, there are some kind of other issues, that communication protocols that you'll have to think about. And so some of these need to be, some understanding of it should be there. But you don't really have to go in depth and understand how these communication protocols are constructed, which is what a computer science students would do. So there are different levels at which you have to teach different topics, right? And then there is things like machine learning, right? There are AI, fundamentals of machine learning, which you have to learn it as part of the core curriculum if you're an AI graduate. And in computer science, you could just do it as one course. Just like I'm saying, systems can be done as one course for AI student, combining 3-4 different core topics in computer science. So 3-4 different core topics in AI and machine learning could be combined as a single course for somebody who is specializing in computer science alone. That's typically what is done now, right? So what people think is, okay, just split those 3 courses into, that one course into 3 courses. Now you have an AI curriculum. But then you don't have the fundamental math for it, and then adding more courses really means that somewhere you have to compromise, right? So it's not clear what are you compromising on. So a lot of, I think, ideally the student learning computer science should be able to build computer programs, computer systems from scratch, right? And the person learning AI should be able to do fundamental research in AI and build, and should be able to engineer together AI systems and solve problems using AI, right? So the solve problems using AI requires you to have a different mindset. Why do I say this? Computer programmers taught from the very beginning about correctness of programs, right? But then in AI, the program can be correct in the correctness sense, but the output of the program will still be non-deterministic in the sense that you will have a neural network, right? But that will give you the right answer only 80% of the time. So when I'm talking about solving a problem using AI, I have to really start thinking about this kind of non-deterministic solution, like probabilistic solutions. While I'm thinking about problem solving in computers, I'm talking about algorithms that always give me a right answer or stop and things like that. So I know the notion of even what is the solution is different, fundamentally different from computing to AI. So I think people need to be taught that difference, right? And they need to be taught in terms of trying to solve problems using a data driven approach, using an AI approach from the get go. So I think that's a crucial difference that we need to tell people between computer science and AI.
In my own forays, little limited, small forays applying AI tools in my domain, I found that it hits success sooner where there is no one right answer, but there is there is a probabilistic framework around the right answer. Yeah. So when we were enamored with ChatGPT in December 22, it's because it wrote a poem on IIT Madras on demand. And obviously, there is no right answer there. And the poem sounded about right. And it was the first time a computer was writing, a poem in verse, and we were all enamored by it. So, does that still hold, or will AI ever get the right answer right 100% of the time? Or is fundamentally the framework itself is such that it is not intended for that as an application?
So we have to step back and ask a question: what is AI? Right? So um, AI is not a single thing, right? AI is kind of a philosophy, right? So it has been applied to a wide variety of different problem solving techniques, right? If you go back to the era of expert systems, right? So there were some amazing expert systems. There was ELIZA, right? There was Mycene. There were these expert systems that were actually tuned for things like psychological counseling or to be a clinical decision support system and so on and so forth. And these were considered AI systems back then, right? What did they do? They were just a bunch of rules. Somebody had a very detailed conversation with a domain experts, more than one domain experts, and kind of codified their knowledge into a very, very elaborate system of rules, right? Now, these again are hard solutions because quite often two experts would not agree on what the right answer is, right? In these domains, like in healthcare, that's why you take a second opinion from other doctors. So people don't always agree on what the right answer is. But the point here is these systems used to give you the same answer all the time, right? If there was a solution on which every expert would agree on, it will give you the same answer. It will give you that answer that which the experts agree on, right?
And that trait is still, it holds true in today's AI models as well.
No, that holds true if you are building a rule based system, if you are building an expert system today, like you did back then. But what has happened today, all these successes since we have from 2010, right? I was telling you about the vision success and so on and so forth, all are based on this idea of what's called machine learning, right? So it's AI has been cursed with not having appropriate names for various things, including AI itself. But machine learning is another one of those terms, right? So the idea behind machine learning is that you capture knowledge by a very large number of examples. Okay, so this is called inductive learning or inductive inference, and the idea of inductive learning goes back to Aristotle. It's nothing new, right? So Aristotle talked about inductive learning. Basically, is it truly possible for you to learn the base fundamental principles of a domain just by looking at examples, right? So when you start talking about inductive learning, if the base of your intelligence is inductive learning, then there is always the possibility that you will not be able to answer questions about things that were not seen correctly, right? So the why inductive learning works is that you make certain assumptions about what do the examples that you see tell you about the examples you have not seen, or not the inputs that you have not seen. You make certain kinds of assumptions about continuity, and you make certain assumptions. So as long as those assumptions hold, you'll be right. When the assumptions don't hold, right, or you do not really have enough knowledge to make those assumptions, right? You are now assuming that this complex neural network will somehow generalize to all these things that you have not seen so far. But if it doesn't hold, then you're going to go wrong, and you have actually no way of bounding how wrong you can go. if these assumptions don't hold. I mean, all the analysis and other things assume that some fundamental assumptions about the data holds.
And the model itself has no way of knowing whether the assumptions have been held. In the old rule-based system, it would tell you are going outside my assumptions in some sense.
I mean, you can still bound it here, but again, yeah, you can still go wrong. Yeah. So that's the fundamental challenge here, right? So you can build AI systems. I mean, rule-based systems are still. I mean, you can still construct them, or things like, for example, Deep Blue, the chess engine, right? That beat Gary Kasparov, right? It did not use a whole lot of inductive learning. It did search. It literally did enumeration of all possible outcomes. Like you're taught to think about while you're playing chess, right? You don't actually do that eventually, but you're taught, okay, oh, you should think about, hey, what are the things that your opponent can do if you make this move? Now, reason about this, and maybe do look at 2 or 3 steps ahead in time and then make a call, right? So those kinds of models can potentially, be more deterministic, more reliable than things that generalize from. In fact, if you can do exhaustive search, right, then you can be correct all the time. But exhaustive search is more often than not possible because of the number of possible outcomes. For example, in chess, right, every move on an average has 35 possible responses that your opponent can make on an average, not every position. So imagine that, right? If you want to look for 10 moves into the future, and it's like 35 over 10 or something. So it's just going to not work out, right? So no, 10 power 35. So it's even bigger. So that's the thing, right? So you can't do exhaustive search. So you have to start making certain assumptions about, okay, this is a useless track. I don't have to explore this, right? He's never going to make this move. And then if the guy actually goes and makes the move, then I don't know how to respond to it, right? So those kinds of things. So everywhere we make certain kind of assumptions and approximations. So that's always going to come back and bite us. But with the machine learning, we have this additional challenge of inductive biases that we don't know how we will react to when the data goes outside the assumptions that we make.
So, in this whole process, there is one question that still remains. Is AI regurgitating from memory, or is there an underlying reasoning paradigm that it has developed? When you ask, let's go to the XOR problem. Today, I'm sure it is able to solve the XOR problem largely, or even more complex problems. Is it based on a reasoning framework, or is it just simply that it has seen something, either the same thing or something very similar, and has learned to remember it?
The whole premise of all this inductive learning setting, right? The learning from examples that we are doing is that there is some kind of an underlying regularity in the data, so that from the examples that I see, I'm able to say something meaningful about the instances I have not seen. So that is the basic premise, right? So when you're asking ChatGPT questions about stuff which has not been explicitly trained on, right, it's still giving you an answer because of the generalization it is doing. It is not regurgitating what it has learned. It is actually generalizing, right? Now, generalization is different from reasoning. Generalization basically says that, okay, A looks like, it's more like analogy, right? So A is like B, so A is to B, therefore C is to D, and that's a kind of thing. It's not quite reasoning. It's just you can think of it roughly. If you want to put it in the reasoning setting, you can roughly think of it as analogy, but it's not that. It is literally interpolation. So I have points, I have drawn a curve around the points. If I now query a point that is between the two data points that I gave you, I'll just go hit the curve, and whatever the curve tells me is the output, right? That's basically what these models are doing, right? On the other hand, classically, AI has developed a whole very rich framework for knowledge representation and reasoning, right? So people have talked about how to represent first order logic formulae, and how do you reason with these and things like that. And ontologies and knowledge graphs and things like that. So a bunch of different things that people have come up with ways of representing knowledge and how to reason with that, right? The challenge for all of these is most of our knowledge representation framework are discrete, right? So that means that they very quickly explode in the number of things that you have to learn, the kind of inference you have to do with it. So people have been having difficulty scaling it to very, very large systems, knowledge systems. There has been so people have worked on it. There's been a lot of success in it, and so on and so forth. So we have AI tools that are capable of doing this kind of reasoning, right? The marriage is still waiting to happen between this kind of inductive learners that learn these generalization and the way to push things around, right? And reasoning engines, right, which use explicit discrete representations and symbol and so on and so forth, right? So that's why people start, of course, as soon as this, of course, it's not new, right? People realize this, so they started talking about something called neurosymbolic AI, right? So where you have the neural network for doing the representation learning and the generalization, and then you have the symbolic thing for doing the that is the ideal. But most neurosymbolic AI doesn't really get there, right? So it just takes some superficial aspects of symbolic reasoning and try to combine it with the representation learning.
So if you start asking AI chat, AI engine, a whole series of why questions, like a 5-year-old would ask, why are there no pink horses in the world? And then the answer, based on the answer, go down. That would be the litmus test of whether the reasoning is more or less watertight, wouldn't you think?
No, because it's possible that whatever chain of questions you have asked, something similar was there on the internet that it actually ingested. So that is why it's so difficult to test these models. You really have to come up with some things which have not been added. So this is why the most of the benchmarks that are there in the world today, I'm not talking about any one thing. Most of the benchmarks in the world today are tainted, because there is a very high probability that that data that you used to construct the benchmark has somehow found its way into training these models at some point.
I think this has been a fascinating conversation about the reasoning aspect of AI. I mean, in some sense, memory and reasoning are becoming indistinguishable from an output test, as from purely output test. You really have, and with, like you said, 580 billion parameters, there's no way for us to go do an inside out test either. It's just unwieldy. From a let's come back to students and what they can do to build a career in this new and emerging world, which will be dominated by AI technologically. What career advice would you give someone wanting to sort of build a career in this space, especially as an early researcher? I'm not sure if I want to go into an academic position, and as you said, AI researchers or AI engineers. Um, I'm a young student. How do I find whether I am ready for one or the other, and what would I do to equip myself to become one of the two?
So let me step back and answer one question, right? So regardless of what you choose to do in your life, so you have to figure out how to do it with AI, because uh, no, AI is not going to take your job away, but somebody who knows how to use AI to do your job is going to take your job away, because the efficiency improvement is going to be significant, right? Even if not all aspects of your job is replaceable with an AI, but you need to know how to use it effectively. It is like saying I will not use Microsoft Office suite, right? I mean, not necessarily Microsoft, but some kind of Office suite, right? You basically have to use that today, right, to survive, regardless of what your job is. So it's like that. So AI is going to become something that's ubiquitous. You have to learn how to do that, right? So regardless of whether you want to get into AI or not. So I just wanted to make that point. The second thing, um, increasingly, the government is trying to push AI into the school curriculum. So if you are now in CBSE, right, you will learn AI in 9th and 10th, right? And in fact, we are working with some organizations to build AI literacy curriculum for grades 6th through 8th as well. So increasingly, you're going to get a good enough exposure to AI, even from the school days, right? And this is going to go to even like government schools, right? So it's not like something that's only limited to some top end private schools in the cities and so on and so forth. So that way, you'll have some idea of what is AI, what it can do. You're going to see the impact of AI around you, and so you'll get a sense of what it is, right? So my strong recommendation would be to start playing around with these AI tools. Right? They are available to everybody. Right? It's become pretty ubiquitous. Right? And then as you keep playing around with these tools, I mean, if you get fascinated by how you can solve new problems using these tools, right? Then you know that you probably want to get into an AI engineering pathway, right? And there are a lot of resources on the web. Like if you go to Kaggle, right? Kaggle is a website that hosts a lot of data competitions, and so they actually have a lot of resources in terms of uh, Gen AI tools also. In fact, they host APIs which you can use to access Gen AI tools through the Kaggle thing. So if you're running a Kaggle competition, you can access, if you're being part of the competition, if you're registered for it, you can access tools using their Kaggle interface. So you should try playing around with those, right? And then figuring out. But then you need to know programming for this, right? But now what I'm finding is kids are learning to write, simple Python code and things like that very early, right? In fact, there are Android and iOS app development courses that are being taught to kids in sixth standard, fifth and sixth standard. I mean, so not this is not new. My son went to one of those, and he started writing all these small games for Android phones and stuff like that because they taught him how to do this development stuff like that. So things. I mean, it's not like coding is something new. So people are getting into this, and so I think I should start playing around with some of these Kaggle competitions or Hugging Face. Hugging Face is a little bit more abstract because it's essentially the same tool chain that people are using for developing actual solutions in the real world, right? Many companies are now building their products based on Hugging Face tool chain, but they do offer these kinds of free courses and free tools and programming and stuff like that, right? But again, this might be for students who are already in college and they want to decide whether they want to branch out into AI as a specialization or whether they want to stick with computer science and things like that. At the school level, it's a little bit more challenging. And yeah, I mean, so we are trying to engage with 11th and 12th kids already, right? So IIT Madras is doing these online courses, which is like a 2-week course on various things. Right now, we have one on AI and data science and AI. I think there is a 2-week course on data science and AI. So again, it's online, so it's not like the bar for getting into these courses is not very high. So you can actually enroll, right? So I would recommend people test out some of these material that's available, right? And there are some things available on Khan Academy as well in terms of introduction to what is AI, what it can do for you, and again targeted at 11th and 12th grade students. So those are some of the resources I would recommend, but it's not an easy question to answer whether you should become an AI engineer or AI researcher. I
That
think.
question certainly is for each individual to answer. But thank you. I think your answer really parsed the problem in the correct way. You at least know the tools that you need. You know the different pathways and the tools available to engineer yourself into those pathways. Like we said, India has about 24 lakh engineering students. Half are in the CS++, half are in CS, non-CS branches. With the idea that AI is going to touch every discipline, what would your advice be to all the civil engineering, mechanical engineering, chemical engineering students out there? What should they be doing to be ready for this world?
So you for example, mechanical engineers or civil engineers all do a course on CAD, right? I mean, so they basically have to learn how to use computer tools to do their job better. So likewise, you have to learn how to use AI tools to do your job better, right? So and these are going to come, and in some places they are getting already standardized. In some places they are coming. So be on the lookout for what is the latest AI development that makes your job easier. For example, in the design space, right? You don't have to design anymore. There are now tools that are coming up and you verbally describe what you want, and it gives you the actual design, right? The mechanical design of the thing that you're describing verbally, and then you can go drag and drop and make some small changes and edits to that, right? And then you get the final product, right? Of course, you need to know what a good design looks like in the first place for you to be able to do that. But instead of actually you sitting and doing the entire design from scratch, you can get these AI tools to do these things for you. So you need to understand that. That's one aspect of it, right? And this is going to be very domain specific, right? And the second aspect, which I encourage everybody, not just engineering people, right? Whether you are doing commerce, whether you are doing law, whether you're doing a doctor, or whether you're even a historian, journalist, whatever, right? Everybody should know what this technology can do for you and what it cannot do for you, because all of us are going to face claims about AI. What AI will do for you, what won't do for you. AI will come and kill you, or AI will influence election, AI will take away your job, AI will make our kids dumber. There's been all these recent studies about how the cognitive abilities of people go down when they keep using AI repeatedly and stuff like that. So people need to understand what this technology can and cannot do for you. And I think this kind of AI literacy is important for everybody, right? I know it should have been this should have happened when we went into social media, right? There should have been a social media literacy effort for everybody, because it's significantly changed how we live today, right? How we interact with people, where we get our news from. Can I trust all the sources, news media that I'm seeing on online, right? So no, you can't. So we should have done that at some point. We did, but I think AI technology is something that's going to be even more pervasive than the online interactions that we have. I think at this point we need that literacy program going.
I think we are past the phase where you can call this hype anymore. There's some real benefits.
And there's still some hype. There is still some hype, but
There's still some hype. Okay, you are the insider. You may know that, but there's some good that is certainly begun to happen, and more will continue to happen. And you already talked of the ethical aspects of you know uh, these kinds of tools affecting people, their behavior, their cognitive abilities. And even so, you talked of the data that goes into training these models not being widely representative of the broader cross section of people. There's some ethical concerns there. What do you suggest people should be wary of, if any, in as we approach this age of AI? What should I be cognizant of?
see, like I said, right, AI is not a single technology, right? And AI is not it's like calculus, right? In some sense, it's being used everywhere in everything, right? It's a very fundamentally it's going to change how things are happening. So for example, if you are a doctor, right, if you're using a AI radiologist to read your x-ray, so you have to be aware of the fact that the AI radiologist might not be able to capture a completely novel phenomenon in the x-ray, right? It might even actually miss it completely, right? Saying not even mark that particular kind of pattern, which a human expert would probably, something would at least bother them, their years of intuition, right? So they'll say, okay, there's something wrong about this x-ray. Maybe I need to take a different x-ray, right?
My layperson says there's like a none of the above option, right? It may not have the ability and power to invoke the none of the above. Is that sort of
See, it doesn't see it.
yeah? The human also has not
No,
seen
it
it.
doesn't see it.
It doesn't see it.
It doesn't see it. It's a lot more fundamental than that, right? Sometimes, you look at a scene and you just don't notice something there, right? You don't notice that something happened in that scene because have you seen I'm pretty sure you have seen it. I'm not sure how many people who have watched it have seen it. The gorilla coming into a basketball game, right? So you keep asking people to keep looking at the basketball that is being passed around, and then there is a gorilla that walks into the frame and goes away. Most people don't even see it. This is like that. When I train the model, right, it is learning certain features by which it will process the image. So if there is a completely new artifact that comes on the image that has never been seen in the training, it might not have learnt a feature to even represent that artifact in its model, right? So it just doesn't see it. I can't even give a none of the above because for me, this looks like a perfectly normal X-ray, right? So I would say it's a normal X-ray. I will not say it's a none of the above.
Whereas the human has an intuition, as you said, that is able to invoke that That none of the above. It's not TB, it's not
Yeah, this
pneumonia,
doesn't
but
look like, yeah. So because we are a lot more general purpose processors there in that sense, right? So I mean, maybe I will keep going, evolve, it will do. So, but the point you asked me, what we should be careful for, right? Depending on what domain you're operating in, right? So you need to know what the limitations of this model is, right? And you need to be aware enough so that you can catch it when it hits those limitations, right? So that's something very important, right? So this is one part of it, right? So this is about the inherent, challenges with using AI for solving very large open domain problems, right? But then there are other kinds of things where AI allows a significant amount of misuse, right? This is something which, so social media, we already have all kinds of fakes, right? Fake news that keeps propagating on social media and other things. It is not like AI is enabled fake news, right? People have been gossiping and rumor mongering and other things have been going forever. What is happening now is a lot of our beliefs, right? A lot of our belief systems, a lot of our checks and balances that we have built over the years for interacting with these things. For example, seeing is believing. Not anymore. I can give you very, very realistic fake image, right? So realistic that people might start thinking, maybe I post for that picture somewhere. That kind of realism, right? That keeps coming in, right? Now these things. So so our natural safeguards, natural whatever you say, right? Filters that we had earlier have to be rethought, right? So so you have to think about fact checking everything, right? You have to, even normal simple things, right? So you have to think about fact checking it, and you need to build the fact checking skills also, right? It's not sufficient to just go on Google, and it's easy to make Google say wrong things. It's easy to make ChatGPT say wrong things even when you are trying to do the fact checking. So it becomes a lot more crazy, right? So I keep saying this to people. It might soon come to a point where if you get a call from your mother, you have to put the phone down, call her back, and verify that whether she actually called. Because, yeah, voice cloning has become so good, and people can even, mine information about you and say that, hey, your birthday is coming 2 days from now. Do you want? And so give you personal information about you in the call. So it might not be sufficient to ask, okay, when is my star birthday? Can you confirm that? It might even actually be able to tell you. So you need to come up with different mechanisms for staying safe online and everywhere else. So I think, yeah, it's going to be a lot more deeper impact on society than we think.
so the old RBI's message that says जानकार बनिए सतर्क रहिए is even more relevant for this than anything else. Ravi, this has been a fascinating conversation. We started talking about your life journey, then where AI and the sort of the historical evolution of AI onto where AI is today, will be a few years from now, when we've passed the different opportunities and educational choices that students make. I think along the way, I'm 100% certain this won't be the last of our conversations, because this is such a fast evolving field that I think our audience needs to hear more validated thoughts. And I'd love to have you back whenever that opportunity allows us to do that again. Okay, lovely, lovely, Ravi. Thank you very much for making this time. This is the Professor Mahesh podcast, supported by IITM Global. I want to thank them for supporting this podcast and having it reach the outside world. This is your place for credible information to help you make informed decisions. We think we want to make sure we bring you future simplified. Thank you.